first shortcut in your book, and this is section 3.3, by the way, right? And so there's a lot of, there's a lot of stuff we got to look at now. So I'm going to do something like this. Here's what I'm going to do for you guys, okay? If you guys look at a function here, like if I said f of x equals c, and yeah, that's for all x. You guys know what kind of function that is? What kind of function is this? What is c anyway? It's a constant. What's a constant? It's a number. So if I said to you, can you now determine f prime x? And yes, you can, but you need to use the what? Definition. Does that make any sense? So you're going back to f prime a, and you say, okay, that's the limit. H goes to 0, and that's going to be f of a plus h minus f of a, everything over h. Is that right? Share with you guys this very, very first formula. Now, what's so nice about a constant function, right? If I said to you, if I replace x with a plus h, what do you think the function's now going to be? This is going to be what now? C. Is that true? It's still C because the function's constant. If I replace x with a, isn't that still going to be what? C? Because you have the constant function, okay? So the limit now as h goes to 0 is c minus c over what? H. Well, what's that going to be? 0 over h. What is 0 over h? Do you guys know what 0 over h is? 0. What's the limit of 0? Isn't that 0? You go, wait a minute. Isn't that the limit of a constant being the constant? And I'll say, yeah. But what did you guys just show? We showed f prime a equals what? 0. Now, what do you guys get to do with the letter A now? Remember we said what you guys want to do? Change it to what? So that's f prime of x equals what? 0. Now, this is deep, ladies and gentlemen. Why do I say that this is very deep? What does that mean? The derivative of any constant function equals what? 0. Yes. But this is why you guys need to know the definition so you can show it. Now let's give you guys some notation here, right? So here's some classic notation. There's a lot of different notation here. If you want, we could leave it. We don't even have time, but we'll leave it that way. How about if I said to you guys, believe it or not, you're going to have another function, so you guys know. X to the nth power, where n is a natural number. You guys know what the natural numbers are? 1, 2, 3, and that goes on what? Forever. Okay? Do you guys know what the derivative of that function is going to be? N x to the what? N minus 1. You say, wait a minute, Mr. Judge. Wait a minute, wait a minute, wait a minute. Okay, so these are some formulas here. This is also a very big deal. This is extremely big, right? So, do you guys remember I gave you a whole bunch of questions like, if I said to you guys, hey, remember this, what's the if your function is what? X squared. I wanted you guys to find f prime of a. Do you guys remember that? If I said, hey, if your function was what? X cubed, I wanted you to find f prime of a. You guys know what I'm saying? Now, we haven't proved it, but we can in our future using the definition. That's how you prove it. But this is the shortcut, believe it or not. Let's see. Can you guys apply the shortcut? It's very simple, but you're going to need practice. Here's what I mean by that. You see that power 2? Right? That's n here. That's 2. So what would this derivative be by the shortcut now? Anybody know? What's f prime of x? Well, you're going to say 2x, 2 minus 1. Double check. Am I using that shortcut? Did I use it? You know what? You know what's going to have to happen now? You're going to need to do some arithmetic. What's 2 minus 1? 1. And then a little bit of algebra. You say, what do I mean? What is any base of the first power? Itself. So, ladies and gentlemen, what you're looking at without using the definition now, and maybe we should go back to blue, but without using that definition, what are you guys looking at? That's the derivative of f of x squared. It's just 2x. How many lines of work was that? 2. And that involved what? Arithmetic. Easy peasy lemon squeezy. Let that sink in. You're going to be using this. This is called, by the way, and it's not really called that yet because I have to give you more information. But this is based on, this idea is based on what we call the power rule eventually. You say, how do I know it's a power rule? Oops, wrong place. How do I know to apply power rule? You have to see x to a what? Oh, to x to a power. So do you see x to a power here? What do you guys think? Say yes. Okay, what is power rule going to do for you guys? F prime x is going to be what? 3x, 3 minus 1. What is 3 minus 1? 2. Okay? So take a look, ladies and gentlemen. You don't have to use the definition anymore. I got to prove it to you, or I might send you the proof. We'll see. But now you could use the what? Power what? Power rule. I'll give you guys the formal power rule, next time. But how quick and easy was that? Was that easy? All right. It's based on what? It's the power rule. So how do you guys know the power rule? You know what? I'm going to give you a recommendation. If you said to me, Mr. Judge, how do I know this power rule? I'll tell you guys the truth. I might forget my name one day. That day might be soon. But I'll never forget these derivatives. I won't ever forget this. You say, why? Why not? Because I gave it a lot of time and energy. And I would always joke, I never learned arithmetic until I took calculus. You go, really? Yeah, because what are you doing here? What is this? What is that? Is that arithmetic? Right? What is this? Is that arithmetic? So we're going to be doing some of these kind of things here with some of these shortcuts. But remember, is a shortcut good? Yeah. I would say shortcuts are good. How do we know shortcuts are good? Well, it eliminates all the work, doesn't it? And that's what's going to happen in your future. You're not going to have to use the definition of derivative anymore. Ooh, I'll say that again. You don't have to use the definition and derivative anymore. You could use these shortcuts I show you, and that's called derivative formulas. And we have power rule, and here's the good news. You got power rule, you got quotient rule, you got product rule.
Also chain rule.
Well, that's first, the basics. Power rule, quotient rule, product rule, and yes, then you'll have chain rule eventually. But chain rule is based on what you're looking at now even. So what happens is this. Don't fall into that calculus trap. I've been teaching calculus for how many years? Oh my God. I don't even want to tell you guys. Probably longer than my first daughter's been alive. And she has a math degree from Cal Poly, and she's going to graduate school at Cal Poly right now. She's doing some data science stuff. Some of my students have her in their classes even. I'm teaching calculus for that long. Now, what will happen is it always does. There are people who are not going to learn any of these rules until the night before. And by then, you have chain rule.
Yeah.
Well, it's hard if you do it all at once. It's like, you ever try to have well, I can think of all these analogies, but we're out of time. But my recommendation is to not procrastinate. Because if you do, what's going to happen? You're not going to be a happy camper. So you want to do these shortcuts when? Now. And though this is going to be this is 3.3. So we just started that, but I'm going to put some homework for you guys, and that's homework 2. I'll put it in Canvas, okay? I think I already did, but we're going to put some more for you guys. I mean, we're going to put that intermediate value theorem that we went over, right? We went over a little bit. We did that example, but it's a simple thing. Just check to see if the value is positive and negative. It's going to be. There's only 4, and it's going to be. So I'll put that there too, and I'll put even here to start to read section what? 3.3. Now, is that all you're really going to do? No, because come tomorrow, what's going to happen? We're going to do some more what? We're going to do some derivative formulas. We're going to have power rule. We're going to have all that stuff. And when do you guys want to get started? ASAP. Don't wait till the night before. If you do that, that's like, we don't have time to get through all the analogies. But anyway, okay, I hope you guys enjoyed the lecture today, and we'll see you guys tomorrow. But today was a theoretical day. Is that right? All right. Take care. So we're 261. We're on worksheets and videos. And ladies and gentlemen, we're going to go over today essentially this, which is derivative by the power rule, and and some properties here. Okay, so we actually described the power rule to you guys yesterday, but I'm gonna go in a little more detail. It's pretty fun. It's pretty easy. It's based on arithmetic and a little bit of beginning algebra, but I'm gonna put that in the chat there. So yes, technology doesn't always work, ladies and gentlemen. So you always got to be prepared, and you got to adapt. If you don't adapt, you're done. That's just general life advice. Failure to adapt and bend, you break. Okay, that's the best advice my grandfather gave me was, Daniel, if you don't bend, you break. So, you have to be able to adapt. So, you know what? If this projector works, great. If it doesn't work, okay. But you know what? It's a face-to-face class. That's what we signed up for. So be it. It worked out for you guys. I think they fixed it when I went over to complain. And they just said, I won't go into the details. I'm just glad they fixed it. Maybe they reboot the machine, or maybe they restarted it or whatever. I don't know. But we're going to work on these things today. All right? So there we go. Power rule and properties. Now, let me give you guys a fact here. Okay? We seen this yesterday. And I'm going to give you some notation. Some of this notation I'm going to recommend you guys use, okay? You're looking at a couple of things here. Okay? This notation is based on, or is used for finding a derivative of a function. Okay, so what goes inside here is what? That's your function. That is f. So f there is there. Now, this is the derivative, this notation right here. Okay? That is your notation for the derivative of the function f. And you say, well, I recognize this, and it's there, okay? Derivative of f. Here you guys go. It's there. So yesterday, what did we call this? You guys remember what this was? This is nx, this is what? N minus 1. What was the name of this yesterday? Do you guys remember? Power rule. Good. This is what we're going to use. We're going to use what's called the what? Power rule. So this is known as the power rule. Okay, and it's the power rule. So anytime you see a function with a power, that's why they call it power rule. This is the rule you use. Now, there's something called a proof. And I'm going to prove this here to you guys. So this is f prime of x, okay? You may say, what happened to the a? Well, we can do the a, but we can also do the x. So this is the limit as x goes to a now. This is a little bit different notation. This is the original derivative notation we gave you guys, okay? It's the equivalent notation. So we've seen a little bit of that theory yesterday with some of that notation. So that's actually the definition. So what they're saying here is your function f of x is x to the nth power. So if I plug in the value a here, okay, f of a is a to the n. Is that true? You guys okay with that? So using this definition, the limit as x goes to a here, you have the following. X to the n minus a to the n over x minus a. Okay. All right. So now, ladies and gentlemen, you might look at this situation and say, what do I do? Well, here's what you guys do. If you actually plugged in the value a for a direct substitution, you're going to get 0 over 0. Is that right? So I just want to be consistent. You get 0 over 0 here. And, okay, so if you get 0 over 0, you know, oh, I got to use some what? Algebra. All right. Now, believe it or not, there is algebra here that you can use. There's algebra. Pre-calculus, what they do, they teach you that they actually teach you how to factor that, I think. This is called the, what is that, binomial expansion theorem? I don't know. Something like that. So you might say, what are you referring to? The numerator. You can factor the numerator. Okay, so here's what's going on here. So if I factor that numerator, x to the n minus a to the n, that's x minus a. And then, believe it or not, that's x to the n minus 1 plus, I believe that's a, x to the n minus 2. And now, what's going on is this. If you guys notice what's happening, this is that expansion theorem from pre-calculus. The powers for x reduce from the n minus 1, and they keep getting smaller, smaller, and smaller, and the powers for a keep getting bigger, bigger, and bigger, until you end up with really at the end, you end up with a to the n minus 1. But before you get there, you do have a to the n minus 2, but I think this would be x, yeah, a to the n minus 2 here. Okay, so you guys can look up that binomial expansion theorem that's, that's used for factoring here. So let's double check. I believe it's okay. X a n minus 2, yeah, plus a n minus 1. All right. And so you might say, how is this helpful? Well, because now you have the limit, x goes to a, that x minus a with this expansion that I just wrote up here. This is all over x minus a. Cancel this out. We get limit x goes to a, x n minus 1, ax n minus 2, x a n minus 2, a n minus 1. And so now you're done. That cancellation is happening, and now you get to plug in your value for a, right? Direct sub or continuity, whatever you want to call it. And we get a n minus 1 a times a n minus 2 a n minus 2 a n minus 1. So now do some algebra here. You get a n minus 1 plus another a. This is properties of exponents right in here from algebra. Okay, so you guys know you add the what? Yeah, and so you're going to get another a n minus 1. And then really for all of them, like even back over here, here's what really happens here. Right, this is the first power. For all of them, you're going to get a what? N minus 1 plus a n minus 1. And you're going to end up at the very end with, ladies and gentlemen, believe it or not, you say, what happened here? You have n of these. Because one of those factors are gone. So you have n of these terms. So you're going to end up now with n a n minus 1. And this was really, I apologize, this is really f prime of a. Okay? This is really f prime of a because you said I ended up with an a, yes. And then now we get to change it, right? So in other words, f prime of a we showed is n a n minus 1. And then you say, well, how did they change that variable to x? Well, it doesn't matter if the variable is x. A, T, whatever. This is the formal proof, ladies and gentlemen, of this theorem here. Now, this is all in section 3.3, so you guys know. 3.3 of your book. Some of you guys are using the wrong book, but okay. It's on page 147, so you guys know. What's that? N of these. There's n of those terms. So you have n of those terms. And this is, to go back in your book here, ladies and gentlemen, I think on page, yeah, there's a general version of this. So it's on page 153 of your book in this section. I want to give you guys all the details because the details are important, right? You have what's called the general version. Because in this version, your value or your power of n is like a natural number, we said yesterday. That power is a natural number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go, really? Yes. However, in the general version, your power rule is the same. But now your power, ladies and gentlemen, is no longer a natural number. It's any real number. So n is any real number. And the proof of that goes beyond the scope of the what? Course. Goes beyond calculus 1, really. Okay? Yeah.
In the test or something like that, do we have to write the proof?
No. No. Okay, you have a good question. You might say, Mr. Judge, why do you care about this so much? Well, on a test, I'm going to say, what if they gave you this on a test, right? They said, okay, x to the 3 halves, and they have to determine your derivative now. Okay? Guess what you guys get to use? Because in this version, what do you guys know about the power here? This is n. Okay? This is assuming your function, right? Do you have to tell them who's calling me? Yes, it's the same formula. However, right, what's your function now? That's x to the n. This is a formula to get the derivative. Why am I talking about today the general version? What's the difference? See your power? N is what? Any real number. What do you guys know about the power here? The power in this case, what's your n? Isn't it 3 halves? Yesterday, n was a natural number, like 1, 2, 3, 4, 5. Today, n could be any what? Real number. That's why I'm saying this is the general version. So any power, any real number power. Doesn't have to be a nice natural number. So on a test, if they give you this and say, I have to get the derivative, you don't use the definition. I wish I had my applause button. I'm not going to go buy that, applause because I may not record anymore. If I can't count on this stuff, And I probably have 5 years of whatever, how many years of videos anyway, so do I really need another year's worth? How do you get the derivative? Use the, what's this called? Power rule.
So we don't have to use the proof that you just gave.
No.
Okay.
So the question is, do I have to prove this? No. I just have to know my power is 3 halves. I keep my variable x, and then what do I do with the power? I reduce it by 1. Okay, you guys okay with that? You go, really? Okay, but here's the price you pay. The price you pay, ladies and gentlemen, for using this shortcut version is you got to know arithmetic. I'm sorry. That's the price you pay. So 3 halves minus 1, you guys remember, that's 2 over what? 2. You guys okay with that? So 2 over 2. Good. So what is that going to give you guys? F prime of x will be what? What's 3 halves minus 1 half? 1 half. And so, ladies and gentlemen, guess what? You're done. Your arithmetic is over. You're done. Is that a lot shorter than using like a definition? You'd have to use like something like this. Yes. So your shortcuts, ladies and gentlemen, here's the thing that people have to get over. Like sometimes, when you give facts in math, people they hate it. They hate any new facts. And they have to understand these facts are helpful. Did you find this fact helpful?
Yeah.
That's my point. Also, recall, what is this? What's the definition of x to the 1/2? Do you guys know what that is? That's a square root of what? X, okay? Okay, that is a definition. So you say, what does that mean? If you look in back of the book, you might see this. And you go, what is that? That's 3/2 square root of what? X. There it is, ladies and gentlemen. That's an example of the what? Power rule.
So it doesn't matter which one, right?
Well, I think eventually you want to use the square root of x notation. Because when you start looking at different solutions everywhere, you're not going to see x to the 1/2 necessarily. I mean, you might, but you don't want to be confused and you go, hey, how did they get the square root of x? You know what I mean? They're using the definition of what an exponential with a rational power means. That means a fraction power. So there you guys go. Look at that, ladies and gentlemen. That's progress. So celebrate your progress, ladies and gentlemen. I mean, celebrate it, because if you don't, you know, I don't know what to say. I mean, you're like, what? I mean, you know, it's kind of like, you know, and then some notation wise, if they said, okay, what's x to the 4th? This derivative, right? As another example. Well, use the what? Power rule. What's the power now? Your power now is what? 4. Okay, what does power rule say?
-1.
4x. 4 minus 1. And when you get, what's the price you pay for the power rule? Arithmetic. What's 4 minus 1? You are what? Done. This is your answer. Okay? There you go, ladies and gentlemen. Easy peasy, lemon squeezy. I don't know. Or would you rather use the definition?
Maybe in some cases, but not.
I think at this point, using the definition is over. At this point, you know, we use the definition to illustrate fundamental things, and, you know, that's really why we use it. But now, since you have a fact that proved the statement, this is what math is, you now get to use this. You don't have to use the definition. You get to use the fact. And it's based on arithmetic. Okay. Give you another simple kind of example here, right? And I'll give you notations. What if they did this and they give that to you guys, right? Now, your function, yes, this is your f of x. You're finding derivatives. But I'm going to have to remind you guys, this here has what? Meaning. That's x to the what?
1/3.
Good. Because remember, the nth root, ladies and gentlemen, of x is x to the 1 over n. Is that right? And that's from intermediate algebra. Go back, nth root of x to the m is going to be x to the what? M over n. So you might say, what do I do with this here? What's your power now? Power's what? Isn't your power now 1/3? Okay, you guys okay with that? What does the power rule say I do? This is going to be what? 1/3 x to the 1/3 minus 1. Is that true? Okay. What's the price you pay for using the power rule? arithmetic. What's 1/3 minus 1? Isn't that 1/3 minus 3/3? Okay, so you're going to get now 1/3 x to the, what's 1/3 minus 3/3? Negative 2/3. There you go, ladies and gentlemen. This is your derivative now. However, you looking back at the book, you're going to see something different. You say, what do I see? Well, they're going to simplify this here by some algebra. Let's go through the properties, right? Isn't this 1 over x to the positive 2/3 power? Is that right? And then isn't this, you say, what does that even mean? Go back here. All right? What is that going to give you? It's a miracle.
It's our server.
Yeah. We're good to go.
So is it a miracle?
No, the server went down.
Oh,
And now they rebooted it. I actually prefer to think of it as a miracle
yeah.
that it rebooted. And now we're up and running. So, yes. So, what do I do with this rational exponent, ladies and gentlemen? What do I do with this 2/3? Do you guys know what I do? Yeah. If you're looking back at the book, you might say, did they use the definition of an exponential with a rational exponent, meaning this is a cube root of what? X squared? Yes. But do not forget, what do you guys have? You have a fraction here. Okay, so now you have what? F prime x, what's that going to be? 1/3, ladies and gentlemen, times 1 over the cube root of what? X squared. So what do you guys see with this? How do you guys multiply fractions? Straight across.
Just multiply.
So f prime x is going to be 1 over 3 cube root of what? X squared. Ladies and gentlemen, you're done. There it is. Easy peasy, lemon squeezy.
Is it okay to write in other ways? Because I got a different answer, but it's the same.
No, I think you want to write it this way. The reason you guys want to write it this way is because where you're headed, it needs to be simplified this way. So, we're not just finding these derivatives, we're going to be using them. And how you use them does require some simplification of the algebra. So you guys want to try that out. Get used to doing it. But in the beginning, you can start to see it that way. And like I said, on my website, you guys remember this? I even have, like I mentioned here, I have videos over these.
How to
I
get the
have some
most
what
of
there?
Grammarly free.
I got videos over that whole thing. So I just want to kind of remind people, you want to get started on this ASAP. If you're that student that doesn't, good luck, And there are people every semester, there are people who they just don't, they won't listen to what you say. That's okay. That's fine. I don't take it personal. But it's a growth opportunity for you, not for me. Because you'll discover what? I should have done what you said. So that's kind of the deal. But I don't take it personal, But that's the derivative now of just the cube root. You imagine if you use the definition. I think we did use the definition on this. Do you guys remember this one? This one had a vertical tangent at 0. Look how short and simple that was. Do you guys remember that one? That was the vertical tangent at 0. That's the one people come and they say, where's our student who, I'm not going to mention names. Remember the request for finding f prime of a? And it was really this, right? For the function f of x is that cube root. So if you guys recall, we actually did this one by definition. We did it. Do you guys remember that? It's in your notes. How fast and easy was this? You just had to know arithmetic and then go back and remember the definition of, or some properties of exponents. We'll put the algebra right here, right? Any power that's negative is 1 over, x to the, n there. You guys remember that algebra? Anyway, okay. Now, I want you guys to recall something here. We did yesterday this property. The derivative of a what? Constant function is what? 0. Do you guys remember that? You want to get used to that notation here. However, we have other properties. If I said to you, what's the derivative of a sum of functions? Okay, the derivative of a sum is actually sum of derivatives. Okay, this is the derivative of a sum. It's sum of derivatives here. Now, the proof of this, and it might be just straightforward to say, Mr. Judge, can I just go do this here? F prime of x plus g prime of x, okay? Now, remember, true, see the proof? You might say, what's the proof of this? The derivative here of a sum of two functions now, we'll say is the limit x goes to a, f of x, okay, minus f of a. Well, there's a couple of ways we can do that. Here's what your book will do. Your book calls this whole thing h. So they're really finding the derivative of h. That's the sum. So they'll say that's h of x minus h of a over what? X minus a. Or, you know what we could do? Yeah, I mean, I don't want to use... I could go back to the other definition, h. But I won't. Limit x goes to a. Now, h of x is really what? F of x plus g of x minus h of a is f of a plus g of a over the x minus a, okay? So now you have that limit, x goes to a. Do some algebra. F of x plus g of x minus f of a minus g of a. And then everything's going to be over x minus a, okay? So all we did was distribute. Now just rearrange your terms. The limit x goes to a, okay? They rearrange to put f of x minus f of a plus g of x minus g of a. Rearrange your terms in your enumerator over x minus a. And now you have the limit x goes to a. Do a little bit of that algebra. This is what I mean. If you can distribute that division. That's what they're saying. So we're going to divide by both terms. And then the limit of a sum is sum of limits. So we have the limit, x goes to a, f of x minus f of a over x minus a. Now, ladies and gentlemen, this is the definition of f prime x, or really f prime a, plus g prime a, and then you could turn that to x. So this is the proof of the limit of a sum, really a sum of limits. Okay, so that's really what we wanted to prove. Now, there's another property, there's a few more. So I'm going to say this, and I won't prove that one, but it's very similar. You might say, what is it similar to? Well, the derivative of a difference is difference of what? Derivatives. The difference of derivatives, right? Derivative of a difference is difference of derivatives. I can say here, I'll say, see, it's the same algebra. See book. Same algebra as the prior property. And then now you have the difference of a constant times a function. Okay? And that's going to be simply pull out the constant and differentiate the what? Function. So the constant here is any real number here is a constant. So, okay, so pull that out.
What's this one called?
Derivative of a constant times a function is a constant times the derivative of the function. Your book does this, because I want to do this too, just so you guys can see the detail. Derivative of a constant times a function is a constant times a derivative of the function. So that's c times what? F prime x. Now, I can do that too. I can prove that to you guys. The proof is in the book. I might say, take a look at the book, because sometimes people want to see examples of that, right? So you might say, see book for now. The proof. But as an example, I'll go back and forth with the notation. If they give you 5x squared, okay, and they want you to find what? The derivative. This is an illustration of the last example we're talking about. What's your constant here? 5. Okay, well, this is what they want you to do. D dx 5x squared, pull out the constant, and I'm going to recommend, highly recommend, use this notation known as operator notation. Use that notation. Because if you don't use it, it can start to become very difficult to do. Okay, I remember my daughter coming home and saying, Dad, I need help with calculus. And it was a question kind of like this. And I showed her here, just use the operator notation. You say, what's the operator notation? The notation you guys see here. Okay. You say, what do you mean by operator? Well, the derivative is thought of as an operator. It operates on a function. So you're saying differentiate, pull out your constant, and differentiate the function. And that's what you see here. operator notation. So you might say, okay, I'm differentiating a function. Oh, now all you need is to do what? What's the derivative of x squared? Okay. I have the constant 5. 5 times what? 2x 2 minus 1. You got to use over here what? This is where you use power rule. So now, ladies and gentlemen, what could you do? You say, is 2 minus 1, is that 1? Yes. And again, beginning algebra, what's x to the first power? Isn't that just x? So, ladies and gentlemen, you have the derivative. It's 10x. Okay, so you can, you can say my derivative is actually what? 10x. There it is. And what if they said, okay, we want you to take the derivative of 3x cubed plus that x squared now? You go, oh, how do I use my properties now, right? So here's the deal. You say, okay, I'm going to differentiate operator notation, 3x cubed plus x squared. So let's ask you guys this question now here, okay? What do you do now? What property should you use? Derivative of a sum is sum of what? Sum of derivatives. What does that mean? Differentiate. Here's what that means, okay? Here's my first function. Here's my second function. Differentiate the what? The first function. And the derivative now of the what? Second function. So here's what it is. So this is a color representation of the derivative of a sum is sum of what? Derivatives. So I write down every step. In fact, you know what I'm going to do now? I'm going to recognize, hey, isn't that a constant times a function? You guys know that first, isn't that going to be, so 3 times what? The derivative of x cubed plus the derivative of what? X squared. Did I pull out the constant? Yes. So what do you guys think I have to do now here and over here? What do you guys use now? Power rule. What's the derivative of x cubed? Is that 3x squared? What's the derivative of 2x? I mean x squared. Sorry, I gave you the answer. Isn't that 2x? Is that 2x? Okay, let's put it all together. 3 times what? 3x squared plus 2x. So the derivative is 9x squared plus what? 2x. You say, how'd you get the 9? 3 times 3. Those are constants. Is that true? So there you go, ladies and gentlemen. We're using these properties here. This is power rule with your properties. This is why we're here to do these here. Okay, and then you say, what if they gave me a function like this? The square root of x minus 3. All right, and you have to find the derivatives. So what What's kind of notation is this? This is operator what? Notation. Okay? There's people who try to do it without it, and then they run into trouble. They try to do these. I mean, you can, but it's not as easy as you think. I don't do it that way. I'll use operator notation. So now, what are you guys looking at? What kind of property you guys think you're going to use now?
You have to like convert the
Yeah, what's the derivative? You're looking at a difference of functions. What's the derivative of a difference? What do we say? Do we have that in our notes? But you said, Mr. Judge, you didn't give me the operator notation. Okay. The derivative of a difference will be difference of what? Derivatives. And yes, that will be f prime x minus g prime x. Okay, so, derivative of a difference is difference now. Okay. So let's see, this is going to be d dx square root of x minus d dx of 3. Okay. Now here's again, you're going to run into this situation a lot. Okay, the square root of x, how am I going to use power rule here if I don't even know what the power is? What do I have to do?
You have to like convert the square root into like the power.
You're going to write the definition of the square root. In other words, it is an exponential to a rational fraction power, right? Remember this. The square root of x is defined to be x to the 1/2 power. Now you can use the what? Power rule. Okay? And you go, 1/2 x to the 1 minus 1/2. And then what's the derivative of 3? Do you guys know the derivative of 3? What's that? 0. Okay. What's the price you guys pay for using the power rule? You have to know what? Oops, sorry, I think I made a mistake. Is that right? Did I make a mistake? 1/2. Yes, I did. Bless you. Let me go back here. Focusing on the colors. Isn't that 1/2 minus 1? Apologize. That's 2 over what? 2. So this is negative what? 1/2. And then 1/2 times 1 over x to the positive 1/2, and then 1/2 times 1 over square root of x, which will be 1 over 2 square root of x. This here is your what? Derivative. So you're using all of your what? Properties. Okay. All right, so ladies and gentlemen, you might say, what if they give me this nice quadratic function and I need a derivative here, right? Okay. Use your what? What's this notation called again?
Operator.
Operator notation. So you want to identify, what are the operations now? You have a what? Sum and difference. Is that true? Okay. So the derivative now, you're going to have what? 3x squared plus 4x minus 5. Why did I put the constants in gray? Do you guys know why? Why did we do that? Well, I'm going to pull out my what? Constant. This is 3 times the derivative of, what's this? X squared plus 4 times the derivative of what? X. Minus, I'm going to keep this derivative of 5. That's a constant, okay? Because what I get to do now here, power rule, I know the derivative of a constant is what? That's 0. But don't forget, you have some what here? 3, 4. Okay. So what's the derivative of x squared? What's the derivative of x? Wait a minute. Derivative of x? Well, what's the power for x? Is that 1? What does the power rule say? 1 times x to the 1 minus 1. I mean, one's a nice real number, isn't it? So I can use power rule here. Okay.
1 times x to the 0.
Do you guys know what x to the 0 is?
1.
Good. Beginning algebra comes in. X to the 0 is 1. Is that right? And then 1 times 1 is? So, ladies and gentlemen, some of these things you're going to see over and over again. And in my mind, sometimes I kind of write down, I think of these facts. Here's some facts in my mind that I think I'll remember for the rest of my life. I'll forget my name, but I'll remember the derivative of the square root of x is 1 over 2 square root of x. I recommend you guys kind of memorize some of those. It's my I mean, you don't have to because you can deduce it by power rule, some of these, right? Here's another. What's the derivative of x? 1. This is the proof of it. If you said, how do I know that? This is a proof. And then you can say, what's the derivative of any constant? We actually proved that already. That's 0. So we proved all those facts. So you get to use facts, ladies and gentlemen. You know, in math, we have facts. So take your 3. Here's the situation. 3 times what? 2x plus 4 times 1 minus 0. What's your derivative going to be? 6x plus what? 4. Okay. Is that easy peasy lemon squeezy? Let's see, ladies and gentlemen. Let's kick this up. Say, Mr. Judge, what if they give me 1 over x squared? And they want me to find the derivative. Do you guys know you only have one formula, do you? Do you guys notice that? There's only one formula called power rule. Is that right? So that's a hint. I only got one formula, really. I got a couple of properties, but I have one formula. So how do I use the formula here? What's 1 over x squared? Isn't that x to the minus 2? So those are the things you need to what? Well, they're from beginning algebra, if you guys remember that. There's actually beginning algebra right here, those definitions. Okay? But my point is, you get to use what rule? What did you learn? Power. What's the power? Negative 2x to the what? Negative 2 minus 1. So, I mean, I'm just going to do a color illustration right there of power rule. All right? Put the negative 2 there. Okay? Negative 2, x to the, what's negative 2 minus 1? It's negative 3. What's that going to be? What have you ever? Okay, I guess we need the general definition, even though I wrote it down, right? X to the negative n is what? 1 over x to the n. So sometimes students will say, Mr. Judge, do I have to simplify my algebra? And I'll say yes, because why? Eventually you're going to use derivatives. And in order to use them, you need to have the simplified answer. So what you're looking at now is really multiplying of fractions. Is that right? So this is negative 2 over what? X cubed. Here's your what? There's your derivative. All right, you guys okay with that? All right, let's give you guys some more examples. Let's said, okay, how about 1 over the square root of x? I mean, did you guys remember by definition, you actually did some of these. I had you guys use the definition and derivative to do some of these. This is a lot shorter, don't you think? All right. So you might say, how do I use my operator notation now, right? So how do you guys think we use that operator notation now with these? Anybody know? What do I write here now? I need a power. I only have a formula called the power rule. How do I write that as a power? Is that 1 over x to the 1/2? And then what is this? X to the negative what? 1/2. Now you get to use your what? Power rule. Okay, what's the power? Negative 1/2, is that right? X to the negative 1/2 minus 1. So what's negative 1/2 minus 1? Isn't this 2 over 2? Which is negative 3 what? Halves. Is that right? Now remember, you're not done. Why do we want to get started at doing things right, ladies and gentlemen? Why? Because where you're headed, you use a derivative. That's the bottom line. So, yes, you want to invest in reviewing your what? Algebra. So x to the minus 1, x to the minus 3 halves is 1 over what? X to the 3 halves. 1 over what? X to the 3 halves. Now this becomes negative 1 over 2 x to the 3 halves. You're multiplying fractions. Is that true? But now we're at a sort of place, ladies and gentlemen. Remember, I think I might have mentioned this to you guys yesterday, right? See this here? You might say to me, hey, Mr. Judge, I looked in back of the book, and the final answer from in back of the book for my derivative was 1 over 2x square root of x. Okay? That's what I got in back of the book. So you might say, how did they get this? Do you guys know how they got it? Let me share with you guys a quick and easy way. Okay, and I think I might even have a video on it somewhere because I think I did it for calculus students. Historically, what you're looking at here is this, ladies and gentlemen. Historically, calculus students, I've had to review this kind of stuff where this is really the square root of what? Of x to the third power, right? And the index there, this is square root, so the index is 2. And so the definition of a radical, really that's not simplified, is when that power here for your variable is bigger than the index. And so this now goes down the road of simplifying a radical. And you go, where do I see that? Oh, intermediate algebra, you simplified radicals, right? And do I have resources on my website? I do. But I'm going to show you what I show calculus students. There's a shorter version. It's a lot nicer. Here's what it is. You guys want to see it? If you guys really want to know what's happening in the world, you know, the Gates Foundation has realized that you guys need remedial education. So they're funding online math courses that you can buy and pay for to learn what I'm showing you here for free. How do you write a mixed number? How do you write an improper fraction as a mixed number? In this 1 and 1/2, you say, what did you do? 2 goes into 3 once. 1 times 2 is 2. Subtract the remainder is 1. Quotient, remainder, divisor. So this is how you write every improper fraction as a mixed number, right? And then I'm going to go further. This is 1 plus what? 1/2, because the definition of a mixed number here is a whole part plus a what? Fraction. Okay, you guys with me on that? Very simple. So if we have x to the 3 halves, that means we have x to the 1 and what? 1/2, which is x to the 1 plus what? 1/2. Is that true? Is that pretty simple? Is that right? Look at that. Okay. And then properties from beginning algebra. Isn't this x to the 1 times x to the what? 1/2. I'm saying focus on this. This becomes what? What you see here. What is this going to be? X, square root of x. Right? So you may have said, hey, is there a property that had something like this from beginning algebra? Yeah. Right? They might have written it down this way, though. That's all I used, beginning algebra and arithmetic. So if you said to me, what kind of skill sets, because I'm on this statewide committee that's going to, rewrite, what kind of math skills people need to go into college level mathematics. I'm the community college rep in the statewide committee where you have a CSU reps and UC reps. What do you think I'm going to say? Algebra and arithmetic. I can teach people algebra if they know arithmetic. I could teach people calculus if they know algebra and arithmetic. But this is what I'm referring to. So now you say, is that why they wrote the answer this way? That's exactly the reason. And I think I do have a video on this exercise. I'm going to dig up. I got to look at my website here because for your homework, what do you think I'm going to do? I'm going to ask you guys to do that worksheet on what? Derivative power rule. Derivatives with product rule. No, let's go back. Derivative, what is that called? Power rule and properties. So, do you have a video on it, by the way? Yes. Where do you click? Where is it at? You click right here, I believe. Okay. So let's put. And remember, I don't have office hours today because I got to give committee reports in a department meeting. So that's where I'll be at a department meeting today. And so I'm going to enter your homework here. And when do you guys want to get started? No. I recommend, yesterday. I mean, that's just how people who are successful, generally speaking, do things. In particular, definitely got to do it in a math setting, right? So what do we call that? Derivative with what? Power rule. Okay, you're going to do the odds. And I do have the videos there, so. Okay, so it helps guide you if you make mistakes or whatever. All right, you guys, see you guys later. Take care. Have a wonderful weekend. Study hard.